The simple answer is no. Once we release the carbon dioxide stored in the fossil fuels we burn, it accumulates in and moves among the atmosphere, the oceans, the land and the plants, and the animals of the biosphere. The released carbon dioxide will remain in the atmosphere for thousands of years. Only after many millennia will it return to rocks, for example, through the formation of calcium carbonate, limestone, as marine organisms' shells settle to the bottom of the ocean. But on time spans relevant to humans, once released, the carbon dioxide is in our environment essentially forever. It does not go away unless we ourselves remove it. In order to stop the accumulation of heat, we'd have to eliminate not just carbon dioxide emissions, but all greenhouse gases such as methane and nitrous oxide. We'd also need to reverse deforestation and other land uses that affect the Earth's energy balance, the difference between incoming energy from the sun and what's returned to space. We would have to radically change our agriculture. If we did this, it would eliminate additional planetary warming and limit the rise of air temperature. Such a cessation of warming is not possible. So if we stop emitting carbon dioxide from burning fossil fuels today, it's not the end of the story for global warming. There's a delay in air temperature increase as the atmosphere catches up with all the heat that the Earth has accumulated. After maybe 40 more years, scientists hypothesize the climate will stabilize at a temperature higher than what was normal for previous generations. This decades-long lag between cause and effect is due to the long time it takes to heat the ocean's huge mass. The energy that is held in the Earth by increased carbon dioxide does more than heat the air. It melts ice, it heats the ocean. Compared to air, it's harder to raise the temperature of water. It takes time, decades. However, once the ocean temperature is elevated, it will release heat back to the air and be measured as surface heating. Scientists run thought experiments to help think through the complex processes of emissions reductions and limits to warming. One experiment held forcing, or the effect of greenhouse gases on the Earth's energy balance, to the year 2000 levels, which implies a very low rate of continued emissions. And it found as the ocean's heating catches up with the atmosphere, the Earth's temperature would rise about another 0.6 degrees Celsius. Scientists refer to this as committed warming. Ice, also responding to increased heat in the ocean, will continue to melt. There's already convincing evidence that significant glaciers in the West Antarctic ice sheet are lost. Ice, water, and air, the extra heat held on the Earth by carbon dioxide affects them all. That which is melted will stay melted, and more will melt. Ecosystems are altered by natural and human-made occurrences. As they recover, it will be in a different climate from that in which they evolved.